conic sections are nothing but the different curves which we get by the intersection of one plane and one cone. So when angle beta is equal to 90 degree, the section is a circle. The condition is beta is less than alpha and it is greater than 0. Then you get a section called hyperbola. We know the general equation of the circle, that is x minus h whole square plus y minus k whole square is equal to r square. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we are starting off with the new chapter, Conic section. Here we are going to study what are conic section and the type of conic section, that is circle. How a circle can be a part of conic or a conic section. Then what do you mean by conic section? Remember, conic sections are nothing but the different curves which we get by the intersection of one plane and one cone. So here I have taken a cone and a vertical cone. So I have kept it like this and I have inserted a plane. So when you insert a plane, you can get a different curves. So that are the conic section. What are the different curves we may get? They are, one is circle, another one is ellipse, another one is parabola, the other curve is called as hyperbola. Apart from this, if you intersect a plane in any particular angle, you will get circle, ellipse, parabola, hyperbola. Also, you may get intersecting lines, point, parallel lines like this. So, you can generate all these types of curves and lines with intersection of a plane and cone whenever alpha and beta are the intersection angle between the plane and a cone. Now let's see how a circle or an ellipse or a parabola or a hyperbola can be generated when a cone is intersected with the plane. So here are the four types of curves which you are studying in your syllabus. So here the first one is circle, ellipse, parabola and hyperbola. So the condition of when an plane is intersecting with the cone, how you will get a circle. So when angle beta is equal to 90 degree, the section is a circle. That is, you can clearly observe. So this is the plane of intersection. When this plane intersect exactly 90 degree towards the cone, you get a curve called circle. Similarly, when alpha comma beta is less than 90 degree, when both the angles, that is intersection between the plane and cone, are less than 90 degree, that is if they are acute angle, then you will get a curve called ellipse. When beta is equal to alpha, the section is parabola. When both alpha and beta, which are the intersection angles between the plane and cone, are equal, you will get the curve parabola. And when beta is less than alpha, the condition is beta is less than alpha and it is greater than 0, then you get a section called hyperbola. Since they are all parts or section of cone, therefore they are called as conic section. So look at the diagram here. We have all the four types of conic sections here. So when a plane is intersecting the cone exactly at the right angle, you can see a circle. So when the cone is intersecting when alpha and beta are acute angle, you will get a ellipse, which is another curve. Next, when a cone is intersecting at particular angle where alpha and beta are equal, the value of alpha and beta are equal, there you will get a curve called parabola. And whenever angle beta is less than angle alpha, and when a plane can intersect both the cones at particular angle, you will get a curve hyperbola. So this is the curve hyperbola. So these are the four parts of conic section which you are going to study them, and also the characteristics of these conic section. So the very first one you are learning is the circle. What do you mean by circle? So previously in your classes you have studied, it's a locus of a point which is at a fixed distance from a fixed point. Or it is a set of all points whose distance is constant from a fixed point. So that is, if this is a fixed distance, there is a point here. So this point is moving exactly at a constant distance. So this fixed point is called the center of the circle, and the fixed distance is called the radius of the circle. So therefore, circle is the set of all points in the plane which are equidistant from a fixed point in the plane. So the fixed point is called center of the circle, and the distance from the center is called the radius of the circle. So in general, we have an expression for the equation of the circle. Let's see what is the general equation of the circle. So the general equation of the circle is given by x minus h whole square plus y minus k whole square is equal to r square, where h comma k is the center of the circle and r is the radius of the circle. How we get this? For example, if this is a circle with center h comma k and this is the radius r. So through the coordinates of x and y axis, we can generalize the expression or an equation for the circle. So that is, the general equation of the circle is given by x minus h whole square plus y minus k whole square is equal to r square. So here we have a question. Find an equation of the circle with center minus 2, 3 and radius 4. We know the general equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. So the center h comma k is given, h is minus 2 and k is 3 and r is 4. Let us substitute this. So this is x plus 2 whole square, because minus of minus 2 is plus 2, and y minus 3 whole square is equal to 4 square. So x square plus 4 plus 4x plus y square plus 9 minus 6y, and this is equal to 16. So you can write this as x square plus y square plus 4x minus 6y. 9 plus 4 is equal to 13, and when 16 comes here, it becomes minus 16. So 13 minus 16 becomes minus 3 is equal to 0. So this is the expansion of the general equation you can write. Let's see the next question. Find an equation of the circle with center 1, 1 and radius root 2. So what is the equation I can write? X minus 1 whole square plus y minus 1 whole square is equal to root 2 square. So if you expand this, is x square plus 1 minus 2x plus y square plus 1 minus 2y is equal to 2, or you get x square plus y square minus 2x minus 2y. 1 plus 1 is 2. When 2 comes this side, 2 minus 2 becomes 0. So this is 0. So this is the equation of the given circle. Next question. Find the center and radius of the circle x square plus y square plus 8x plus 10y minus 8 is equal to 0. So here we have to reduce it into general form so that we can find the center and radius of the equation. So we have x square plus y square plus 8x plus 10y minus 8 is equal to 0. Now let us separate the x terms, that is x square plus 8x and y square plus 10y. I'll shift minus 8 to that side, so it becomes 8. Now completing the square method, using this, let us complete this square. We have x square. This can be taken in the form of 2ab, so 2 4s are. That means 8x, so 4 square is 16. So complete the square, plus here y square plus 10y. So 2 5s are 10 means, so 5 square you have to take 25. So whatever you have added on the right hand side, add the same thing on the left hand side, that is plus 16 plus 25. So now this can be written in the form of x plus 4 whole square, and here it is y plus 5 whole square, and when you add this, you will get the value as 49. So the general formula is x minus h whole square plus y minus k whole square. So this can be written as x minus 4 whole square plus y minus 5 whole square is equal to 7 square. Now you can compare this with the general equation. So therefore, center h comma k, here it is minus 4 comma minus 5, and radius r is equal to 7. So this is the center and radius of the given circle. Next, find the center and radius of the circle x plus 5 whole square plus y minus 3 whole square is equal to 36. Let us write in the form of general equation. So it is x minus 5 whole square plus y minus 3 whole square. 36 can be written as 6 square. So therefore here center is h comma k. That means here it is minus 5 comma 3. And radius r is equal to 6. Next question. Find the equation of the circle which passes through the points 2 comma minus 2 and 3 comma 4 and whose center lies on the line x plus y is equal to 2. We know the general equation of the circle, that is x minus h whole square plus y minus k whole square is equal to r square. Now, since the equation of the circle passing through 2 points, we can take the values of x and y as 2 comma minus 2 and 3 comma 4. Since it passes through 2 comma minus 2 and 3 comma 4. So let me take this as equation 1. You can replace the value of x and y as 2 comma minus 2. So we get, from the 2 points, we can write it as 2 minus h whole square plus minus 2 minus k whole square is equal to r square. And we get it as 3 minus h whole square plus 4 minus k whole square is equal to r square. Take this as equation 2 and equation 3. So from these two equations, we can compare it and we can find the values of h and k. And one more equation they have given, center lies on the line x plus y is equal to 2. That means since center lies on x plus y is equal to 2, this implies the value of h and k is equal to 2. So you are getting h plus k is equal to 2. So solving all these 2, 3, 4 equations simultaneously, so we get the value of h is equal to 0.7, k is equal to 1.3 and r square is equal to 12.58. Solving all these equations, so therefore our required equation is x minus 0.7 whole square plus y minus 1.3 whole square is equal to r square is 12.58. So this is the general equation of the circle for the required problem. Next, find the equation of the circle passing through the point 4, 1 and 6, 5 whose center lies on 4x plus y is equal to 16. So the same thing here also we take, since it passes through 4, 1 and 6, 5, we can write the equation as 4 minus h whole square plus 1 minus k whole square is equal to r square. Take it as equation 1. Again I can write it as 6 minus h whole square plus 5 minus k whole square is equal to r square. Next, they have given the center lies on the line 4x plus y is equal to 16. So from this equation, I can write this as 4h plus k is equal to 16. So solving all the equation 1 and 2, 3 simultaneously, we get h is equal to 3, k is equal to 4 and r square is equal to 10. So these are the values we get. So therefore, the required equation of circle is the required equation of circle is, so that is x minus 3 whole square plus y minus 4 whole square is equal to 10. Find the equation of the circle with center 2, 2 and passes through the point 4, 5. So we have a circle whose center is 2, 2 and it is passing through the point 4, 5. So somewhere here let me take this point as 4, 5. So this is the distance, that is radius. So therefore I have a equation of a circle where center is h, k and radius is r. But here they have given the center but radius is not given. By applying the distance formula, here I can find the radius of the circle. So radius can be taken as r square is equal to x2 minus x1 whole square, y2 minus y1 whole square formula, which becomes 4 minus 2 whole square plus 5 minus 2 whole square. So which is 4 plus 9 is equal to 13. So therefore r square is equal to 13 and center is given as 2, 2. So therefore the equation of the circle is x minus 2 whole square plus y minus 2 whole square is equal to r square. R square is here 13. So this is the required equation of the circle. Next, find the equation of the circle with radius 5 whose center lie on the x-axis and passing through the point 2, 3. So here the radius is given, so r is equal to 5 and center lies on x-axis. So on x-axis y value is 0. So therefore it will be in the form of h, 0. Now, it is passing through the point 2, 3. So, since it is passing through two, 3, what we can write? We know the general equation of a circle is x minus h whole square plus y minus k whole square is equal to r square. So, substituting here, we get this as 2 minus h whole square plus 3 minus, the k coordinate is 0 since center lie on the x-axis. So it is 0 whole square and here it is r square which is nothing but 5 square. So now here we get it as 2 minus h whole square is equal to 25 minus 9 which is equal to 16. So we get it as 2 minus h is equal to plus or minus root 16. So h is equal to plus or root 16 plus 2. So root 16 is nothing but 4. So here we get it as plus or minus 4 plus 2. So according to it we get h is equal to minus 2 or h is equal to 6. So now we have two values for h. So let us substitute this h is equal to minus 2 or h is equal to 6 as an equation. So therefore the equation of a circle, so when h is equal to minus 2, the equation becomes x plus 2 whole square plus y square is equal to 25. And another equation, when h is equal to 6, it may be like x minus 6 whole square plus y square is equal to 25. Since the coordinate of y is 0, we will get it as y square. So the next concept is point inside, outside or on the circle. How to recognize whether given point is inside the circle or outside the circle or exactly on the circle. So let me consider a point P of x, y. So if the point P is inside the circle, the distance from the center P will be exactly less than the radius. If here CP is the radius, I have taken the modulus value here because it shows the distance is always positive. So the radius will be always greater than the distance, or I can say the distance from the point to the center is less than the radius when the point is inside the circle. If the point is on the circle, then exactly the distance between the point P is same as the radius. That is radius will be equal to the distance of CP. If it is outside the circle, then the distance of the point from center will be greater than the radius. That is, modulus CP is greater than R. So, how to calculate CP? Again, using the concept of the distance formula, h minus x plus y minus k whole square, where R is the radius. Like this, we can find whether the given point is inside the circle or outside the circle. So, let me show you through an example. So, let me consider a circle with center minus 1, minus 3 and radius is equal to 6. So, consider the point minus 6, minus 6. Let's see where does the point lie, whether it is inside the circle or on the circle or outside the circle. So, let us calculate the distance CP, that is the modulus value we take. How we can take? By using the distance formula. So, minus 1 of minus 6 becomes plus 6 whole square. Again, minus 3 minus of minus 6 is plus whole square under the square root. So, let's see this. Minus 1 plus 6 is 5. 5 square is 25. Next here, 3. So, 3 square is 9. So, we will get the value as 34. So, it is root 34. Now, what is the value of root 34? It is approximately equal to 5.8 something. So, clearly we can say the distance of the point from the center is less than the radius. That is, 5.8 is strictly less than 6. So, what we can conclude? If the distance of the point from the center less than the radius of the circle, that means the point P lies inside the circle. So, what we can conclude here? Here we can conclude point A is inside the circle. So, the other two cases may get like this. If mod CP is equal to R, then the point is on the circle. If mod CP is greater than R, then the point lies outside the circle. So, in today's session, we have discussed how you get the parts of cone or the sections of cone when you intersect any plane. So, the four major curves you are going to learn is the circle, ellipse, parabola and hyperbola. Today, we have discussed the characteristics and how to form an equation of a circle with a given condition. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.